Welcome back, students. In this class we study the chapter real number, exercise 8.3. So first problem. Here we first see what is a rational number and what is an irrational number. See, this one I have written the definition here. A rational number is a number expressed as a fraction p by q of two integers q not equal to 0. Example is minus 3 by 7 and 2 by 4. Irrational number. So this is the rational number. Irrational numbers are numbers that are not rational. They cannot be expressed in the form of the ratio of these integers. So as the rational numbers, these cannot be expressed as the ratio of the two integers. So example is root 2, root 3. So we'll start the exercise problem. First one is prove that all these definitions, everything you will be studying in the theory part. So I am solving the exercise problems. So prove that root 5 is irrational. So for this we have to prove this as irrational. So for solution assume, we have to first assume root 5 is a rational number. So first an assumption is made, that is root 5 is assumed as a rational number. So next step, then root 5 can be expressed in the form, that is in the form a by b, where a and b are co-prime integers, that is co-prime integers. So integers and b not equal to 0. So we are trying to prove this one as, we are assuming this as rational numbers, and then root 5 can be expressed in the form a by b, where a and b are the co-prime integers and b not equal to 0. So next step, root 5 is equal to a by b. So after this, squaring on both sides, so we'll square this here, that is root 5 the square is equal to a by b the whole square. Now after squaring, this cancels, root cancel, 5 will get then a square by b square, which is equal to a square will cross multiply this one, then a square is equal to 5b square, which we can take it as equation 1. So now next is this one, 5, we can write it as 5 divides a square. This can also be written as 5 divides a. So we have a theorem in the textbook, that is theorem, I'll just write this is according to the theorem. So what is the theorem? So I'll write the theorem here. This one is theorem. Let just refer this. This is according to this theorem. Let p be a prime number and a and a be a positive integer if p is a prime number, a be a positive integer, p divides a square, then then P divides A. This is the theorem. So according to this theorem, we are solving this problem. So this is the statement of the theorem. Next step is now we take A is equal to 5m. A is equal to 5m, then square on both the side. A is equal to 25 on squaring this, 25m square both sides, square on both sides. So substitute A square is equal to 25m square in equation 1. This is theorem, we will take it as equation 2. So here substituting this in equation 1. See what is equation 1. So I'll write here. Equation 1 is A square is equal to 5b square. So on substituting A square, we get 25. M square is equal to 5b square. 5 and 5. Then we'll get 5m square is equal to b square. Now we can write as 5 divides b square, but also we can write as 5 divides b. 5 divides b by this one we'll name it as theorem 1. So in the bracket we can write it as by theorem 1. So give this one expression as 3. So after this we can write it as thus from equation 2 5 divides A, and equation 3, that is 5 divides B. So this means 5 is a common factor. 5 is common factor of A and B. So this contradicts next statement. This contradicts that there is no common factor. Common factors of A and B. So contradicts means the opposite or the negation of this statement is means this will become false. Contradict of this statement means if this one is true, the contradict of this will become false. Negation of false. So in this case, when both are true, 5 is true means negation of 5 should also be true, then this proof will be correct. So here contradicts of this is there is no common factor of A and B. Hence we can write it as root 5 is irrational number. So irrational number, hence proof. So it is a Already in the definition we proved that this root 5 is a rational number, but in order to prove, we just assumed it as a rational number. After all these steps, we came to the conclusion is root 5 is an irrational number, hence proved. This is the solution for this first one. We move on to the next, second one. This is the first problem. So you have to write each and every step. So assuming this, since they have given in the problem that is a rational number, we have to assume a irrational number. We have to assume it as a rational number, and finally we have to prove this, that is it is a irrational number. So we move on to the next question. Next question is, that is, prove that 3 plus 2 root 5 is irrational. Here also we'll start the solution. That is, assume 3 plus 2 root 5 is rational number. Then it can be expressed in the form that is A by B, where A, B are co-prime integers. Means they are co-prime integers. So I'll tell you what is co-prime integers, and P not equal to 0. So co-prime integers are, they do not have any common factor except 1. So the numbers, I'll write numbers which does not have any common factor or numbers which does not have common factors other than 1. Common factor other than 1. So example I'll write, that is 4 and 7. See, 4 and 7 does not have any common factor except 1. So this is the solution. After this we come back to the problem. Here in the problem we have 3 plus 2 root 5 is equal to A by B, where A, B or integers, and B not equal to 0. So next step is on rearranging this number, what we'll get, root 2 root 5 is equal to, we can write it as A by B is equal to 3, or we can also write it as root 5 is equal to A by 2B is equal to 3 by 2. This can be rewritten like this. First write 2 root 5 is equal to A by B is equal to 3, or we can write as root 5 is equal to A by B into 3 by, means this one is, this 2 comes here and also 2 comes here. This comes here and here too. So this can be written as. So next step is, since A, B are integers, and B not equal to 0, therefore A by 2B is a rational number. A by is a rational number, and a by 2b minus 3 by 2 is a rational number. Since this a, b are integers and b not equal to 0 in both the case, is a rational number. So this, so the difference now, this is a rational number, this is a rational number, so difference of these two will also be a rational number. So this can be, you write here, difference of two rational numbers is also a rational number. So every definitions I am writing, please refer this. So after this, we just write, here we have the other side, we have root 5 is a rational number, is a rational number. Now next step is, but we have to write root 5 is an irrational number, irrational number. So this shows, next step, this shows that assumption is incorrect. So what we assume this as a rational number, but the assumption is incorrect. So finally what we can write? Finally 3 plus root 5 is irrational. So this is the solution for second problem. So we move on to the third one. In the third problem, prove the following are irrational. Here the first problem we'll take, that is 1 by root 2 is given. So what is the first step means? First step is assumption. Assume 1 by root 2 is rational. As we know, that is root 2 is irrational. So co-prime integers rational. Next we have to write co-prime integers p and q. Every time we have to write this p and q not equal to 0, such that we'll take this root 2, 1 by root 2 is equal to p by q. So next step is, what happens? 1 into root 2 by root 2 into root 2. So if we cancel, we get the same, that is 1 by root we'll get back. This is equal to p by q. So now what happens? Simplify this and write. We can write it as, so what happens? That is, we'll get simplifying root 2 by 2, which is equal to p by q. This is equal to, we can rewrite it as root 2 is equal to 2p by q. So after this, since next step, since p, q are integers, and q not equal to 0, therefore 2p by q is rational. So this is, see, the condition is satisfied, both are integers and q not equal to 0 is rational. So this implies what? Root 2 is irrational. This implies that root 2 is rational. So but contradiction, but last line, but this contradicts fact that what root 2 is irrational. Root 2 is irrational. So finally, what is the conclusion? So 1 by root 2 is irrational. So what is the meaning of contradicts? Means if root 2 is rational, the contradiction of this should also be rational, but in this case root 2 is rational, means the contradict of this will become irrational. So finally we have to write, so finally root 2 is irrational. So we proved that it's an irrational. So this is the third problem, first sub problem. In the next class we'll continue the third problem. If you have any doubt, comment me, subscribe my channel, share, like all the videos. Thank you.